Alright, so for today we are going to still solve quadratics by factoring, but what you see on the paper is that some of the equations are not equal to 0 like they were yesterday. So that's our difference today, or one of the differences today, is that our equation must equal 0 today. Alright, so as we look at number 1, we want this to equal 0. So what needs to happen?
You gotta subtract or add.
You want this negative 22x to go to the other side, and so that means we would add it. So let's go ahead and add 22x to the other side. And so what happens over here is that they cancel out and we get the 0 that we wanted. On the left-hand side, you'll notice that this is an x squared and that this is an x, and they can't be added together to give us one thing. So we have to write them separately. Now, let me remind you that a quadratic equation, the general form for that, write this down at the top of your page. This is the general form of a quadratic equation, where you have your x squared term first, then you have your x term, then you have the plain number. It should be in that order. For when you get to doing the rooftop method, you have the first and the last terms and you have the middle terms in the right order, okay? So we want to put the 33x squared first, then we'll put the plus 22x, and now it looks like it did yesterday. So our very first step in the quadratic process when we factor is to look for a greatest common factor.
11.
11, not just 11.
11x.
11x. So 11x times what gives us 33x squared?
3x.
And 11x times what gives us 22x? Plus 2. Alright, so now we've got it factored. Look inside the parentheses. Can this be factored any further? Is there a squared here? No. So then we are able to now solve each equation or each factor equal to 0. So 11x equals 0. We are setting that equal to 0. And then 3x plus 2 equals 0. What do we do on this one? We're actually looking at the 11x one. Divide by 11, and x would equal 0. Now we can subtract 2 on this one. And 3x is equal to negative 2. Then what? Divide by 3. And x equals negative 2/3. So then our two answers would be negative 2/3 and 0. All right, let's look at number 2. Number 2, is it equal to 0?
No.
No. So we want it equal to 0 here.
So gotta add 18.
We're adding 18. Good. We'll add 18 to both sides. And again, we've got to keep in mind the order that we should put them in. We want the n squared first, then the minus 9n, then the plus 18, and now, of course, the equal 0 because those go away. First step in the factoring process is to look for a greatest common factor. Is there one? No. Are there 2 or 3 terms? 3, so that means we rooftop. So then n squared times times 18 is 18n squared, and we need to add to a negative 9. So we think of all the numbers that will multiply to 18 squared. And then they have to add to a negative 9. I see a positive 9. Change both of these to a negative, yes. So that's what's going to replace our negative 9 in the polynomial. So now n squared minus 3n minus 6n plus 18 equals 0. All right, what's the next step in our rooftop process? No, we're actually going the opposite direction. We want to group them now. Yes, we want to group them. So n squared minus 3n plus negative 6n plus 18. All right, then we look for the greatest common factor in each of the factored parentheses. We've got n for the first one. N times what will give you n squared? N times what will give you negative 3n?
Negative 3.
Thank you. And then what's the greatest common factor of this one?
Negative 3.
Higher. Negative 6. Good. Remember, we want the greatest common factor. Negative 6 times what gives us negative 6n? N. And negative 6 times what gives us positive 18? Will it be a positive 3 or a negative 3? It should be negative because negative times negative will give us the positive that we need. And also the n minus 3's in the parentheses will be the same. So then we end up with n minus 6 and n minus 3, and we still have it equal to 0. At this point, we need to break it up into two separate equations. So n minus 6 equals 0 and n minus 3 equals 0. So we can add 6 and get n equals 6, add 3, and n equals 3. So our two answers here, our two solutions are 3, 6. Questions? All right, let's look at number 3. Does this one already have equals 0?
Yeah.
Then we're ready to factor. So I hear rooftop. Was there a greatest common factor on this one? No, that's why we're able to go ahead and rooftop, because there are 3 terms. So this would be negative 10x squared that we're multiplying to, and a positive 3x. Okay, so these are the numbers that I've come up with. I haven't found one yet.
Put the negative on the 2.
Put the negative on the 2. Good. So then that makes what we need to replace that 3x. So we have 5x squared minus 2x plus 5x minus 2. All right, once we have it into 4 terms, we do what? We group them. What's the greatest common factor of the first set of terms?
5. X.
Just an x. So we end up with 5x minus 2. Here's a really big question right now. What is the greatest common factor of the second parentheses?
There's not one, so you put them on.
Exactly. If there is not an actual letter or a real number, 2, 3, 4, whatever, you have to have something, so you have to say that the greatest common factor is a 1. Okay? So then this would be a plus 1, and that's 5x minus 2. All right, so then that means because these are the same, we can write our 2 factors. It is okay to have a greatest common factor of a 1. Biggest thing you need to learn on that one. All right, then once we have our 2 factors, we separate them into 2 equations. X plus 1 equals 0, and 5x minus 2 equals 0. So what are we going to do on this one? Subtract 1. X equals negative 1. On this one, we can add 2, and then what? Divide by 5. So then we would end up with negative 1 and 2/5. right, let's look at number 4. Is this one equal to 0?
Yes.
Yes, it is. So we're able to go ahead and start the factoring process. First thing in the factoring process is to do what?
Find the greatest common factor.
Find the greatest common factor. So in this case, what is the greatest common factor?
3.
It is a 3. Excellent, Christian. So then 3 times what gives me 75r squared? 25r squared. 3 times what gives me negative 48? Minus 16. You're close. Minus 16. All right, so what we have left, we have 2 terms. What is that? Are we ready to just start solving, or do we have to do something else?
I'll do something else.
We have to do something else because there's a squared there. It is the difference of squares, Aaron. Thank you. Remember that the difference of squares says the same number multiplied by the same number gets us that one. So what is that for this 25r squared? 5r times 5r. And what about 16?
Negative 4 times 4.
Put one negative on there so that we can make our 2 parentheses out of it. We still bring down the 3. We have 5r minus 4 and 5r plus 4. What's our next step?
Subtract.
Can't just subtract yet. Really, really important step is to
Eliminate, distribute, substitution. Separate.
separate them and make them into different equations. Very good, Lawrence. So we make the 3 equals 0, the 5r minus 4 equals 0, and the 5r plus 4 equals 0. We have to separate them into their own equations. But can 3 equal 0?
No.
So then that just disappears. The greatest common factor does not always disappear, though. If you look at right here, the 3 here disappears. But this greatest common factor, the answer was 0 because there was a letter there. So that makes a difference, okay? So then this would be plus 4 on both sides. 5r equals 4.
And then divide it.
Divide it by 4, and r is 4/5. And then on this one, we can subtract 4. And divide by 5, and r equals negative 4/5. So then our 2 answers are negative 4/5 and positive 4/5. Okay, let's go on to number 5. They have a greatest common factor. Yes, it's equal to 0. That's what we needed. And they do have a greatest common factor of 4. Do they have anything else in common?
D.
A D. So then this would give us 25 minus what?
1D squared.
1D squared. There's 2 terms here. Is it the difference of squares?
Yeah. Yes.
Even though it's backwards, it is the difference of squares. The 25 can break down to 5 times 5, and the D can break down to D times D, and since that's a negative, one of the D's gets to be negative this time. Even though it's backwards, that's okay. It still is the difference of squares. All right, so then we bring down our greatest common factor, and 5 minus D, 5 plus D. So this time, how many answers are we going to have?
3.
What's the highest exponent that we have?
3.
The highest exponent that we have is a 3. That highest exponent tells us how many answers we're going to have. 3 has 3 answers. 2 has 2 answers. If we were just to do a plain simple equation, 2x plus 3 equals 10, the highest exponent is a 1, so we have 1 answer on that one. X equals whatever. Okay? So, let's go ahead and separate this into 3 equations. 4D equals 0. 5 minus D equals 0. And 5 plus D equals 0. All right, so how do we get d by itself on the first one? Excellent. So d is equal to 0. And then what do we do? Subtract 5 minus d equals negative 5. Divide by negative 1. And d is equal to 5. And then on this one, we want d by itself, so we just subtract 5. And d is negative 5. So on this one, we have 3 answers, 0, 5, and negative 5. There's one more. Is this one equal to 0?
No.
No.
So we add 4a.
Okay, if we move that 4a to the other side, that's going to make it a negative 4a. When we factor, unless it's the difference of squares, we want to try to make sure that it's always a positive squared term. So that means we want to leave this here, 4a squared, because it's positive, and we want to move the other terms. This one here, the 20a needs to move to the other side, and the negative 25 needs to move to the other side. So what are we going to do with the 20a? We'll subtract it. What are we going to do with the 25? We're going to just do it all in one fell swoop. These two go away, and we're left with the 0 that we want. Can we add any of these together? No, they're not the same like terms. So we're going to have 4a squared. Remember, put them in order. We want the a squared term first, then the minus 20a, then the plus 25. Does it have a greatest common factor?
Yes.
It does.
No.
No.
There isn't one here. And it has 3 terms. So that means you do rooftop with that. So we multiply to get 100a squared, and we add to get the middle term, negative 20a. So we've got 1a times 100a, 2 times 50, 4 times 25.
Wait, 3 times 75.
Oh,
Hey,
3 times 75 would be not working, because that would be like 200 and whatever. 3 times 75 is not going to work. No, that would be 150. 3 times 75, no, that would be 215. 25. Thank you, 225. 5 times 20a would be 100a squared, and then 10a times 10a. Right, so since this one adds up to 20, but we need it to be a negative 20, we have a negative 20a.
Yeah.
So that's what's going to replace the negative 20. So sometimes it feels like you're not getting one. You're not getting one of the factors that's going to work, but sometimes you have to keep going until you've gotten all of the factors listed out. Okay, so it's important for you to try every factor that's there. All right, let's go ahead and group them. What's the greatest common factor of the first one? So that would be 2a minus 5. And what would be the greatest common factor of the next one? Negative 5, good. So this would be 2a, and remember, a negative times a negative would give us the positive we need. And since these are the same, we're able to write down 2a minus 5 and 2a minus 5. Our last step here is to separate it into 2 equations. So we have 2a minus 5 equals 0. 2a minus 5 equals 0. So that's the exact same factor. Do we have to do the solving on both of them, or is it going to be the same thing?
Same thing.
It's going to be the same thing. So let's just do it on one of them. Plus 5 on both sides. So 2a equals 5. And then if we divide by 2, then a would equal 5 over 2. And so on this one, you're only going to get one answer, 5/2. Now remember I told you yesterday that you could use your calculator to check it. I would like to look at the graph of this one. If I was to type in 4x squared minus 20x plus 25, the answer here, there's only one. And remember, these answers that we're getting, that's where it's crossing the x-axis. So what this answer is telling us is that this graph is only touching the x-axis one time. So I want to see what that looks like on the graph. Does everybody see it? It doesn't cross more than once. It only crosses one time. It hits it and then it goes straight back up. One solution here. Remember, we can have two solutions. In this case, we can have one solution, and then tomorrow we'll see that there is a time that there may be no solutions, no real solutions here. Are there any questions on what we've done today where you've had to make it equal to 0? All right.